Hi friends, let me explain you about the hybridization. Hybridization is the concept of mixing the atomic orbitals into the new hybridized atomic orbital, which will give rise to the shape of the molecule, or which will in turn influences the geometrical shape as well as the bonding structure. Here, let me take the sum of the hybridized types. That is the first SP, SP2, SP3, DSP3, DSP2, D3, SP3, SP3D, SP3D2. These are the types. The examples are written. Let me tell you about the structure, how that is formed due to hybridization. In the first molecule, beryllium atomic number is 4 and the electron configuration is 1s2 2s2. Here the valence shell electron is 2s. In the excited state, the 2s which contains electron 2 here in the 2s orbital, 2s, the one of the electron that will jump to the p orbital. So here it is a 2p. So hence in the excited state, the beryllium atom distribute the electrons into the s as well as p. Hence it is called as sp hybridized. The structure of the molecule is linear in the second one, the boron, here the atomic number is 5, electronic configuration is 1s2 2s2 2p1. In the excited state, the valence shell electrons will shift from the s orbital into 2p orbital. So that means 2s 2p, hence we call this as sp2 hybridized, which is trigonal planar structure, which is in trigonal planar structure. And the third one, here the methane or water molecule. Let me take the water molecule here. The oxygen, its atomic number is 8, and here the electron configuration is 1s2 2s2 2p4, and here when it goes to excited state, from the valence shell electron, the electron will jump from here, it is a ground state, in a ground state, okay, 2p, 2s and 2p, and the is a ground state, and in the excited state, the electron will jump here, excited state, so both 2p, here all three will possess the equal energy. The reason is because already it has two unpaired electrons, where the hydrogen can pair up its electron with the unpaired electron which is present in the 2p orbital of the oxygen atom. Hence it is tetrahedral in structure. Tetrahedral in structure. The water molecule structure though it is a bent, but when it is considered the structure is bent, but hybridization is sp3. Next, in dsp3 hybridization, we know that nickel atomic number is 28 and the ground state electron configuration is I'll write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Now valence shell electron falls at the level of D and 4s, and here the nickel cyanide, in the excited state, here it is 4s, 3d, and here it possesses 2 electron and 3d8. Here in the excited state it is Ni2 plus. So from S the orbital will become vacant, and though the ligand which is attacking into the central metal ion, that is nickel, is a strong ligand, hence it will pair up. So because of that, here now the p orbital is vacant. Here the vacant orbital is d and s and 3p orbital. Hence the shape of here the cyanide groups can share its electron, their electron, with the empty orbital of the nickel metal atom. So the shape of the molecule is dsp3 is trigonal bipyramidal. So you can see the structure, that is Ni and with the cyanide and upper one and below one. Next, the dsp2, here it's also the same. So the nickel 28, and the excited state, it will show here the s orbital, it is nickel Ni2 plus. Here also due to the presence of that, here it will pair up the electron. Next, the cyanide, four cyanide groups can pair up, share its electron in the available. So hence it is dsp2. Structure is nickel cyanide is a square planar structure. Next, D3sp3 iodine, it's a valence shell electron, is is 5s2 5p5. So here the ground state, and here 3 electrons and 5 electrons. Due to the arrangement of the hybridization, whatever the paired electrons will shift to the d orbitals. So because of that, it will carry one electron, and the remaining will shift to 3 more will shift to the other. So here the fluorine can pair up or bring its electron, so hence cell. So hence the shape of the molecule is pentagonal pyramidal. Pentagonal bipyramidal.